Now, our topic for today is scalar and vector quantity. Now, don't forget in our first topic in first term, that is SS1 first term, we've classified this same quantity into fundamental and derived quantity. We have some quantity that serve as basic for others, while some are derived from combinations of two or more other quantities. Now, we still want to reclassify these quantities into vector and scalar quantity. That is, we discover that we have some quantities that have both magnitude and direction, where we have some of them that have only magnitude, they have how big they are. Then we call those ones that have how big they are alone, we call them scalar quantity. Now, when we say scalar quantity, we mean those quantities that have only magnitude, they have how big they are, but there's no direction. For instance, look at the distance. So you can say, I ran and I covered 20 kilometers. Nobody knows the direction of your movement, but you just told us the distance covered. In that case, distance is what? Scalar quantity. But we say, I ran towards northeast for 20 kilometers. In that case, you have told us how big the distance you cover is and the direction. So in that case, we call it what? Vector quantity, and that is what? Displacement. Just like when somebody wants to move, let's say somebody wants to move from point A to point B. So you may decide to move like this, come to this point, to this point, to this point, come back here before coming back to the final position. So this one has no specific direction. We call it distance alone. But if somebody says, I want to move from point A to point B along eastern direction. So in that case, he has told us the distance and as well as what? The direction of his or her movement. So we call it displacement because it's a vector quantity. Now, how are you going to identify vector quantity from scalar quantity? So when we say vector quantity, we mean those ones with magnitude and direction. Now, if you are given many quantities, so like this one now, these are the examples of scalar quantity. We have distance, we have time is also part of it. Nobody can say, okay, what time says? After telling the time, the person cannot ask you of what direction of that time. Say, what time says 2:30? Well, it's not possible for that person to say, in what direction? Because time does not have direction. The same thing applicable to temperature. I'm having temperature. So nobody will say in what direction. The same thing applicable to mass. The mass of this object is 20 kilograms. They cannot ask you of direction because it does not have direction. But this one, displacement, velocity, acceleration, force, all of them, they have their own direction. For instance, someone says, the man hit me with what? With force. You can say, what direction? He hit me in this direction. So in that case, we call it what? Vector quantity. Now, how are you going to use formula? You can use formula to identify vector from scalar quantity. For instance, in case of speed is also scalar quantity. But what are the derived quantity of speed? We have distance over time. If you look at it, distance is a scalar quantity, then time is a scalar quantity. So combination of this scalar and scalar will give us scalar quantity. The another one is what? Volume. Volume is length times breadth times height. Length is scalar because it's a distance. Breadth is also scalar. Height is also scalar, it's a distance. So combination of them will give you volume, which is also what? Scalar quantity. But let's try to take that of speed, velocity. So for velocity is displacement over time. So see, this displacement is vector. So this one becomes vector. Look at acceleration. Acceleration is velocity over time. So velocity is vector quantity. This one is vector quantity. So this one is also vector quantity. Now another one is this. Look at force. Force is mass times acceleration. So acceleration is a vector. So therefore, force become vector. But the use of formula like this is not common. It's not general, sorry, it's not general for all of them. We have some of them like that that may not lead to vector quantity. For instance, when we say energy is equal to force times distance over time. Though force is a vector quantity, so it does not make this energy to become vector. That's why to identify scalar from vector, we have some of them you get from formula. While we have some of them, just look at it and say, okay, can somebody ask me direction of this quantity? If they cannot ask you direction, to me, that thing is a scalar quantity. But if it's something that they can easily ask you direction, to me, it's a vector quantity. Now, this so-called vector quantity, they have their characteristics that we can use to identify them, especially when we are calculating. Now, in the addition of vector, you can easily add 20 plus 10 together in the case of scalar quantity, that it will give you 30. That's for scalar. And for vector, it's not always that 20 plus 10 will give you 30. If the two vectors, they are parallel to each other and they act in the same direction, they are going to give you 30. But if they act in opposite direction, the result will be what? 20 minus 10, which is 10. But if they are perpendicular to each other, then they will still give you another thing. If they act at certain angle, it's like 60 degree or 30 degree, you still get another thing. You use cosine rule. If they are perpendicular, you use Pythagoras theorem. So therefore, vector quantity has some characteristics that we need to consider. The first one is they have both magnitude and direction, which appear in our definition of vector quantity. The second one, they do not obey ordinary law of addition, like I said. While the last one, either magnitude or direction or both of them can change the resultant. So the resultant of vector can be affected by either magnitude or direction or both. But in case of scalar, it's only magnitude that can affect the resultant. So this is where I'm going to stop for today. So the next one will be addition of vector quantity.